This time I give you a function f of x equals to 2x plus 3 over 4x minus 1. I want you to find its inverse function, f inverse of x, using algebra. There are 3 steps. The first step is you swap the row of x and y. So you write this first. You write y equals to 2x plus 3 divided by 4x minus 1. So I only change f of x to y, right? So you swap the row of x and y. So the y becomes x and the other x becomes a y. So 2y plus 3 divided by 4y minus 1. And then you have to do algebra to isolate y on one side. You may think this is impossible because we have 2 copies of y. It is possible. So you multiply both sides by the denominator. So x times 4y minus 1 equals to 2y plus 3. So now we just get out of the inverse function, rational function. Distribute x, 4xy minus x equals to 2y plus 3. Put all the y on the left and all the x on the right. So you have 4xy minus 2y equals to 3 plus x. So now you factor our y. So once you factor our y, so now you have 1y left, 4x minus 2, and that equals to 3 plus x. And then let's switch over here, and then you have y equals to 3 plus x divided by 4x minus 2. Isolate y on one side using algebra, and then you change this to y inverse equals to 3 plus x over 4x minus 2. Or you can write f inverse of x equals to 3 plus x divided by 4x minus 2. It does just depends on what your instructors want. So if you're doing homework online, I don't know, read the problem, see which one they prefer. I accept both. All right, so let's do the blue one. So the blue one, we have f of x equals to the square root of x minus 2. I gave you the domain and range as well. So first of all, you change this to y equals to square root of x minus 2. And then at this point, we still have x greater than or equal to 2 and y greater than or equal to 0, right? Domain and range. So now we start the process, swap x and y. So we have x equals to the square root of y minus 2. All right. So now you swap the row of x and y. So this time becomes y greater than or equal to 2 and x greater than or equal to 0. You have to switch x and y. Switch, right? Another way to think about this is the domain of f is the range of f inverse. Look, the domain of f is the range of f inverse. The range of f is the domain of f inverse. But why is this the domain of inverse? You still use a y. I will show you how to do it in a minute. Okay, how do you put the y back on one side? Square both sides, right? X squared equals to y minus 2. And then you have x squared plus 2 equals to y, right? So therefore, you have y inverse equals to x squared plus 2. Or you have f inverse of x equals to x squared plus 2. And then what about the domain and range? So now you just you just find the f of inverse. So now the domain is x greater than or equal to 0, and then the range is y greater than or equal to 0. I mean greater than or equal to 2. Does that make sense? Does that make sense? So the range is here, right? Y greater than or equal to 2, and then the domain is right over there. So when x is greater than or equal to 2, you pick something 0 or above. Y is always greater than or equal to 2. So even though you pick x equals to 0, which is the smallest possible x, then the smallest possible y is y equals to 2. So this is done. Don't just practice the algebra, practice the domain and range as well, because I am sure when you got this problem on an exam, you will be asked to take care of the domain and range as well. All right. How about absolute value? absolute value. So here is how you handle absolute value. So first of all, you have y equals to absolute value of x minus 2. And then swap x and y. So you have x equals to absolute value of y. I should just do it here. So x is equals to absolute value of y minus 2, and then I should add swap x and y. When you swap x and y, you have to swap the inequality as well. So now y is greater than or equal to 2. So y is greater than or equal to 2, and x is greater than or equal to 0. When you swap the row, you have to do this on the domain and range as well. So now do everything you can to put the y on one side. Look, this one, the reason I picked this is because this can be broken down into two functions, into two equations. The first one is x equals to y minus 2. And then the other one, you have to put an or right here. X equals to negative y minus 2. Because that is how you solve equation involving absolute values. And then this one is x plus 2 equals to y, right? So you have y inverse equals to x plus 2. And then on the other side, divide both sides by negative 1, negative x equals to y minus 2, and then you have 2 minus x, right? You have y inverse equals to 2 minus x. Now, the conjunction is still an or, so which one should I pick? Oh, by the way, before I get into the or, why do you need to break this down into two pieces? Because think about this. Think about the graph of y equals to square root of x. The graph of y equals to square root of x is a v, right? So one on this side and then one on this side. On the first quadrant, you have x. On the second quadrant, you have negative x. So this is a y equals to x and y equals to negative x. So that's why you have to take care of the negative as well. Now, which piece do we want? The one on the left or the one on the right? The answer is you have to think about which piece satisfy this domain. So the domain is, I should put this back to this color. So the domain is x greater than or equal to 0, and then the range is y greater than or equal to 2. Does this piece satisfy the domain? When x is greater than or equal to 0, so let's say x equals to 10, greater than or equal to 2. Hold on. Did I copy something wrong? Okay, here. I'm going to use a different color to fix it. X greater than or equal to 2. Y, x less than or equal to 2. So x less than or equal to 2. This is not a mistake. We have y greater than or equal to 0. And then which is when you swap the x and y, this is x greater than or equal to 0. And then the y in here is correct, but the inequality sign is flipped here. Is less than or equal to 0. Based on this. So this one should be y less than or equal to 2. Less than or equal to 2. So this one, when you pick the first piece, when x is large, so let's say x equals to 10, 10 plus 2, then that is not less than or equal to 2. So basically this one we have to omit. That does not satisfy the domain. So does not satisfy the domain. So does not satisfy the domain. Then this is the inverse function. Because this one, when x is like 100, y is less than or equal to 2. So this is the one that we want. The first piece doesn't satisfy the domain. You have to check this at the end, and that's why I pick a function involving absolute value. And then the problem can be a piecewise function. This is easy. So this one for most of the piecewise function, when you draw a horizontal line, use the horizontal line test, you have two intersections. So the horizontal line test basically fails. So this piecewise function has no inverse function. All right, and then how about the parabola? If you still remember the previous lesson, a full parabola does not have an inverse. Here is y. So you have y equals to x squared, x equals to y squared, when you take the square root on both sides, you have plus or minus square root of x equals to y inverse. So that means you will get y inverse equals to positive square root of x, y inverse equals to negative square root of x. And then here is the positive square root of x. Let me use a darker color to draw on the picture. This is positive square root of x. This is negative square root of x. In fact, this is not a function at all because the vertical line test failed. When x is equals to 3, y is equals to, let's pick an easier number. When x is equals to 9, I should just give you that on the picture. So when x is equals to 9, y is equals to positive 3, and y is equals to a negative 3. So this is a 1 to 2. Function must be 1 to 1. So this sideways parabola is not even a function. So that's why f of x equals to x squared has no inverse. And then in fact, if you check apply the horizontal line test at the very beginning, it doesn't even pass the horizontal line. So if it doesn't pass the horizontal line test, it won't pass the vertical line test. I think that's all the possible case scenario that we can cover, and then this is also the end of this lesson. If you like the way I teach inverse function, give me a thumbs up, a subscribe, and I will meet you all in the next video. Signing out.